Hello, this is Junichi Horikawa, and today I'm going to show you how you can create a time displacement or slit scan-like effect using Unity on real time using your webcam as an input. Now let me first show you some examples what this slit scan that I'm going to create. Okay, so if I play this and it shows up the webcam. Now let me change the camera to my view. Now as you can see, my face is distorted like you see on the display horizontally. Now this is the effect that I want to create today using Houdini on real time. Using together with a ShaderGraph. Okay, so let's do this. First of all, let me explain an algorithm in order to achieve this effect. So first of all, say you have an image, a webcam image, which changes on real time, and you first create a bitmap grayscale image covering this resolutions. Could be like a grayscale gradations from white to black, something like this. Next you want to have a array of textures which is retrieved from each timeline. So say this is the current timeline, and this is the past time, and from some frames ago to the current time frame, you want to get several textures out of a webcam. So say this is the current frame webcam image data, texture data. This is the one that is one frame before, and so on until the past frames. So you define the number of textures you want to retrieve as the past, as a time sequence, and together with this gradient information with the texture information right here, texture arrays right here, you can convert from white to black into an index value for this texture array, maybe from 0 to a number of textures -1, and use that as an index to access to one of textures from past to current. And by doing it, you can replace those pixels which corresponds to this grayscale value with those corresponding texture image. So replace those pixels with the pixels from the chosen textures, and do that for every other pixels, and as a result you'll be able to get the effect that I have shown, like a time lapsing, a time displacement, or slit scan effect. And I'm going to show you how to do this using a ShaderGraph on Unity, since it's going to be pretty fast to create calculate the texture effect. Well, only downside is that creating procedural textures at each frame is a bit expensive, so you cannot create a huge high resolution textures on real time since you gotta have to create several number of textures. So that's gonna take you some time if the resolution is too high. So we're gonna keep the resolution small enough so that we can use it for, you can create real-time effect. Now, often when you create this kind of effect, people tend to use like After Effects to use as a post-processing, but creating as a real-time is pretty fun to do, so let's do that. So let's start by creating a initial project from scratch. So since we're going to use a shader graph, we're going to choose either high definition render pipeline or universal render pipeline. And I will choose universal render pipeline because it's a bit cheaper. Okay, now let me name this project something kind of understandable. So slit-scan. Okay, let's first set up the scene that we need. So open up the sample scene. Well, currently we are in the sample scene. Well, we don't need this kind of model, so we're gonna create a new scene and then save this as inside the scenes folder named as slit-scan scene. Okay, and let's try to create some several pieces that I need. So I am going to use a canvas in order to draw the textures that I'm going to create using the shader. So create a canvas first, then let's create a panel or maybe a raw image so that we can apply either texture or material. Okay, I'm gonna use just have place the raw image. Okay, it doesn't show up. Okay, now let me change the canvas to a world so that it corresponds to the camera as in a world coordinate. Okay, and I'm going to change the camera type to orthographic. Then first let me change the size of the canvas to, first of all I'm going to set the position to 0, 0, then set the width and height to say 100 by 100 so that it's easier to remember. Now for the raw image, I'm going to keep the width and height attached to the canvas, so do it like this. Okay, looks good. Now go back to the camera, and the camera has to cover all the area for the canvas except for the height part especially. So this orthogonal size 50 should cover all the size for this canvas if the canvas is 100. Okay, looks good. Now the position for the camera seems to be okay. Let me change this position Y for Z. Okay, I mean Y to 0, and everything else looks okay. Now we are ready to create a material which is going to store the shaders in order to draw a texture that I want as a final result. Okay, so I am going to create a material folder first. Material, there are materials right now. Okay, and I'm going to create a material called a slit-scan matte. Okay, now I also need a shader. So let's create a folder to store the shaders. Okay, now let's create the shader with the ShaderGraph. So create shader. I'm gonna choose the PBR graph. Okay, and I'm gonna name this slit-scan shader. Okay, now let's open this up to edit. So what we want to have first is a texture, the array of textures as an input. So we're going to create a property for the texture array, texture 2D array right here. And let's name this as textures and set the name for the reference as underscore textures. Alright, now bring this up, and we also need a UV in order to access to a pixels on each textures. So create a UV. Alright, now what we want to do first is create a gradational map from black to white. Doesn't have to be like horizontal gradation or vertical gradation, could be any kind of grayscale image, but let's just create a grayscale gradation because that will be really simple to create from this UV. Okay, so first I am going to split this UV into X and Y using split node. And so the Y value is actually already a gradational value from 0 to 1. So we can directly use this as a black gradation, grayscale gradation image. And what we want to do next is to convert this gradational map value into an index for the textures. To do that, we need to know how many textures are stored inside this textures 2D array. Now, I don't think there are a way to retrieve that using a node, so let's create maybe this one. Not sure, maybe not. That this should be for a vector. Now, so in order to retrieve the textures, we're going to create another properties, maybe for integer or vector1, as length of textures. Okay, so I'm gonna name this textures num, and we're going to access this from a CPU side using C# code later on. Underscore textures num, right? Okay, let's bring this up as well. So this is going to be the total number of textures stored inside this texture 2D array. Now, in order to create an index, what we can do is to first multiply this texture number together with a Y value for the U, V, which is going to be the V value. So it's going to be the vertical gradation value. Okay, so let's set the texture num default to 1 so that we can see the result as a gradational value. Okay, now next thing, since the the index is an integer value, so let's convert this into a integer by using a floor. Now there is a chance that you are left with 0 or 1 in this case, and if there's only one textures, you don't want the value 1, so we are going to create another node. If the value is equal to the number to the texture num, then we are going to subtract it by 1 using a minimum node. Okay, and create a node again to subtract the total number of textures by 1. Okay, and make this be the minimum number for the index. Okay, now we have created the index in order to access to the texture array, this one. So let's try to access to this. Okay, and the node what we can use is sample texture to the array, this one. Now this is the texture to the array, and the second input is the index, so this will be the index. And UV, for the UV we can just directly input this UV value. So bring this up to right here. Oops. Connect like this. Okay, now finally we can put this color value to either albedo or emissions. Well, since we're just dealing with camera in 2D, I'm gonna put it in emissions, and also set the albedo to black so that only the emission will show up. Okay, looks good. Now this is all it for the shaders. I'm going to save this and go back to the material folder and assign a shader that I have just created. So that was slit-scan shader. Okay, and as you can see, there are two parameters that you can input for this material. Now we're going to access it through a C# code that I'm going to make next. Okay, so I'm going to first create an empty game object and also create the script to control the slit scan effect. I am going to name this as slit scan manager. Sum this up. Okay, so first what we need to do is to access to a web camera, right? So let's do that first. We are going to create a private class, a private property or private variable for Webcam Texture. So Webcam Texture, and let's name this Webcam Texture. This. Okay, and let's try to get this value, initialize this on a start by webcam textures equal to new webcam textures, and we need to define the width and frame rate or FPS. Okay, so for the frame rate, let's also have that as a variable. So I'm going to create a private int target frame. Let's say 30. And well, that will be the maximum. This will be the maximum for the target frame. Now let's also change the applications framework, target framework, similar to the FPS that we're going to retrieve from the web textures. So application target frame rate is equal to target frame. And for the new web textures, we need to define the width and frame rate, but we don't really know what's the resolutions for the devices, so because it depends on what device you use, what webcam you use. So let's first create a reference integer to be small enough, because we don't need that much big image for this tutorial. I mean, for this examples, like I said, if it's too big, then the calculation will be too slow because we need to initialize text on each frame. So we're gonna make the initial size rather small, and I'm gonna name this ref width or ref size maybe as 128. Okay. And let's use this to initialize the webcam textures. Ref size, and target frame for the FPS. Okay, and in order this to work, we need to start play so that this will start working, start capturing the images from the webcam. Then go to the update and check the webcam width, how does it changes. Okay, so initially when it started to play, it starts from really low resolution like 16. Then when it initializes the actual webcam device, then it starts to give you the real result, the real width for the webcam. So let me save this and go back to Unity and attach this slit scan manager that I have created to a empty game object. Okay, did it like this. Okay, and play. And at some point you see this size. 1920 is the real size, and before that you had value 16, which is pretty small. So these are the value when the webcam is not initialized yet, and after 3 frames it starts to initialize and have the real webcam size. Okay, now let's go back. Now that we have checked, we need to kind of resize these textures into small textures, so in order to store in an array with the number of textures that we're going to define. So we need to create several public variables. First, I am going to create I'm going to create a integer to define the number of textures. So texture num, and then let's initialize this number with 50 for now, and let's have a private variable for actual width and height that it's going to be stored inside the texture array. Okay, now we also need to access to a row image right here, as well as the material informations right here. So let's try to access that by creating a serialized field. So public, starting from material, let's name slit-scan mat, and public, we need a row image, so row image slit scan row image. Okay, now after we have retrieved the image, we also need to scale in the width direction, in the x directions, because currently the row image, the size of the row image is square, right, as you can see, but depending on the aspect ratio of the webcam, we want to scale this up to width directions. So to do that, the easiest way we could use is using a component called aspect ratio filter, and we can change the size of it by changing this ratio right here. Maybe set the aspect ratio value to say envelope parent, and change the aspect ratio, and you can change the size either on the height direction or width direction based on the image information, the webcam texture information that you get. Alright, now let's open up the code again, and let's give a serialized field for that aspect ratio fitter. So public aspect ratio fitter, aspect ratio fitter. Okay, so and we also need to create a texture 2D array as well. So let's have that as a variable as well. So private texture 2D array text array. Okay, so that should be enough in terms of the variables that I need. Okay, so after I have started, we need to check if the webcam has been initialized or not. So I'm going to check it by checking the width value of this webcam textures. So if it's bigger than 16, then that means it should be initialized. So if webcam, inside of update, I'm going to just run one process to initialize all the values that I need, such as texture to the array. So if webcam texture width is more than say 100, then let's do the initialization. So to do that, let's also create a private variable for the boolean called init. Start with the false value. Okay, and so if init is equal to false, then we want to initialize several values. So let's make a function called init outside the void update. So somewhere around here. Okay, I might have too many curly bracket. Okay, so I'm gonna name the new function called private void init. And inside here we're going to initialize several stuffs. First of all, I am going to access to the preview, the slit-scan row image and material, and assign a slit-scan material itself. Now you can also create an instantiated material for this one, but for now I'm just going to directly input the original prefab material right here. Okay, now we need what I want to do next is to change the aspect ratio of the row image. So I'm going to access to the aspect ratio fitter and the property called aspect ratio, and change that by a webcam textures width divided by a webcam texture height. That should work. Now let me check this first. And in order to check this, we also need to check what the textures apply to the row image. So for now, I'm going to, instead of setting the material, I'm going to instead set the textures directly to the texture property with the webcam texture, and see if the texture has been successfully stored, displayed in the row image. Okay, let me save this, go back, let me play this and change the webcam to my face. Okay, now I seem to have some errors. Let's go back. Okay, 47. Okay, well, I forgot to put those serialized field. So for the slit scan material, I'm going to input this one. For the row image, which this one, and aspect ratio, which is inside the row image as well. So drag and drop that. Okay, that should be enough. Let's play again and see if I see anything. All right. Now that we have image applied on a row image like this, now it's time to rescale the texture from the web texture because it's too big. It's currently 1920 by 1080, so that's too big. Let's make it small as possible. For now, I'm going to use this ref size as a reference width, and based on this value, I'm going to also scale the height as well. Okay, so first of all, I'm going to create a scale value between using a ref size variable and webcam texture width. So float scale is equal to ref size divided by float webcam texture width. Okay, now let's create a final width and height, which is right here, for the texture to the array size. So width is equal to webcam texture webcam texture width multiply by scale, and height is equal to webcam texture height multiplied by scale. Now I also want to convert this into integers, so let's say math f floor to int and convert it into an integer. Okay, this one as well, so I'm just gonna copy this, convert it into an integer like this. Alright, now we can start creating a 2D array, texture 2D array. So initialize texture 2D array with new texture 2D array, and for the parameters there are several stuffs. We want to derive the types from the webcam textures. So well, first of all, the width and height we already have defined it, and for the texture format we can create, well, there are no texture format for the webcam textures, so I'm going to just choose by myself texture format dot, I need a RGB color, so I'm gonna choose RGB 24. Then for the force parameter, we can choose, what we can choose is this MIP count, which can be retrieved from the webcam textures. So MIP count. And for the linear, let's just say true. Okay, does this enough? Okay, maybe not. Alright, what else do I need? Okay, well, I forgot to set the depths for this to texture to the array. If I look at the guide again, if I go at the code hint again, see that I need to set width, height, and depth. So depths will be the number of textures you wanna store as an array. So we already have that, which is a variable called textNum. So I am just directly apply this textNum to the third input, and that's good. Alright, now next what I want to do is to access to a shader on the material and then set some properties that I have created. One is a textures, so I want to apply this text array what I created into a shaders textures property. So to do that we need to access to a material, which was slit-scan mat, and do set texture and set the access to the textures property by writing a reference name, and this is the texture that I have created right now. Okay, and also I am going to set another properties for the material, slit scan mat set integer, and this time it's the number of textures. So textures num with a text num. Okay, so as initialization this should be enough. So I can bring this back and remove this. So right now the raw image is applied with the material with the shader that has several textures created. Okay. Now what I have to do next is inside the update we need to create a row or array of time sequence textures. Okay, so let's do that. And I am going to use try catch just in case there are some sphere errors. Okay, so try curly bracket catch exception or system exception E, and inside try I'm going to create the time sequential textures at each frame. Okay, so first of all I need to scale the webcam textures because it is right now too big, and the size has been already been chosen using this init function, which is equal to width and height. So what I want to do is to scale this web texture into a new texture with a width, a new width, and new height. Now in order to scale the textures, I am going to use a script from some user called texture scaler. So I'm gonna like copy paste this and use it as it is. The problem is that it doesn't accept webcam texture, it only accepts texture 2D, so we have to modify this a bit, but it's not that too hard to do, so let's just do it. I'm just going to copy all these code. Okay, and then the name of the class is texture scaler, so let's create a script same name as that. Let's create a texture scaler. Okay, and edit this, paste the code that you have copied, and we're going to use this scaled function with the webcam 2Ds, webcam texture 2D. So I'm going to copy this and paste and just change this input to webcam texture. And let's see, what else do I need? Now this GPU scale right here, which is this one, also needed webcam texture input. So let's copy this as well, paste it right here, and change this to webcam textures. Now seems like I cannot use apply, so let's comment this out, and everything else should be okay. Alright, so this should work. Let's try this. Okay, now going back, and let's create a code to scale down the texture first. So to do that, I'm going to create a private variable, called small texture, name for a texture 2D. So texture 2D small text. Okay, and let's create this inside an update, inside a try, by using the texture scaler function, texture scaler class that I have just imported. So texture scaler dot scaled, and using this you can convert, you can create a new textures from a source image, which in this case a webcam texture, with the new size, width, and height. Alright, now after you have created, you want to have this texture being stored as a newest time textures inside the text 2D array. So to do that, I'm going to access to the last index of the texture 2D array, so that can be done by text array dot set pixels 32. I'm gonna use 32 instead of just set pixels, because this doesn't use much CPU than the set pixels functions, because there's only from 0 to 255. Okay, so small text. First of all, in order to what I want to copy as a value is the value from this small text. So I'm going to use a small pixels, get pixel 32. That will be the value that I want to copy to this text array. And then for the second parameter, I need to specify the index for this texture to the array. So, and I want to choose the end index, so I can say it like text array depth -1. And other than the last index, we need to shift the textures to the by one frame. So the previous newest texture should go to one past frame back, and that one past frame back texture should go another frame back, to go to the another past by one frame, and do that until you shift all the textures inside the array. So first we need to access all the textures except for the last one. So we're gonna use for loop text array depth -1 like this, and text array set pixels 32. And what we're going to do is to shift the pixels, right, from the newer to the one frame past. So the newer pixels can be retrieved by i+1 accessing to the i+1 index. So text array dot get pixels 32, and the index is i+1, and we're gonna we're gonna copy that value into an index I, meaning we have just shifted the color pixel value. Okay, for that texture to another texture, to the past texture. Okay, now after we have set the pixels as a final, we need to apply to update the pixels, and we no longer need the small textures. So in order to garbage correctly, we need to destroy it in small text. Okay, now I think we have got all the necessary informations right here. Let's test this out. Okay, let me play. And okay, nothing's showing up, so something must be wrong. Okay, let me check what seems to be wrong. Okay, first of all, it is all grayish. And let me first check if the material has been successfully being applied. Yeah, it seems like so. Okay, and seems like this texture has not been applied to this one. It says none, so maybe I'm missing the assertion part, which is this one. Now I'm calling init right here. Okay, well, after we have initialized it, we have to say init is equal to true, so that we don't need to do initialization every time. That might be the reason why it didn't work. Let me try again. Okay, maybe not. Okay, let me go back again, and let me check what is needed. Okay, so let me first go back to the shader edits file and check the name of the property. So it is textures. Okay, and the texture is num. Right, now let me see. So textures num text. Okay, spell mistake. All right, now when I have fixed the spell mistake, let's see if this works now. play it, and here you go. So let me change the camera to my camera. Yeah, seems to work well. All right, and currently the resolution is 128, so it's pretty low res, as you can see. And as you might be able to see the slit scan line right here. So this is caused by the number of texture that I've created. So the the height is being divided by 50 currently, I think. So if you go back here, maybe you can also promote the resolutions values, which is currently set as 128, which is this one. So let's make this public instead of private so that you can change it inside this inspector. Now if I change this ref size to 256, you'll get a better result. You'll get a better resolutions like this. Nice. All right. Now let's change this text number to smaller value, like 20. Let's see the effect. And you see that the scan line range, or the length height, becomes a bit higher, bigger. You can see a line in between becomes longer. And you can also see that the image that you're seeing is refreshing in real fast, faster than before. But then if you set it to 100, then I think it's going to be a bit slower. Like this, the scanning becomes really slow. And the image that you're going to get start to get really distorted based on the time, which is still interesting. All right. Okay, so let's bring this back to 50, and this is it. This is how you can create a slit scan effect or time displacement effect using Unity together with the ShaderGraph on real time using your webcam. Okay, so that's it. Thank you. Thank you very much. If you like it, please press the like button and subscribe. Okay, thank you, and see you next time.